Today we're going to learn how to write Rust extensions in Python. Similar to how we can write C and C++ extensions, we can also extend the Python language with Rust. So this means we can write components in Rust and then use them in Python, which can oftentimes lead to a massive speedup. If you like this video, let me know by hitting the like button and subscribing. But now let us get right into it. Alright, so we're going to learn how to extend Python projects using Rust in this video today. So we're going to write so-called extensions, Rust extensions for Python, or some people say Python extensions written in Rust. I'm not sure what the correct phrasing is here, but the idea is we write Rust code and we use the functions that we write in Python, which can oftentimes lead to massive speedups. Now, in this video today, I want to focus on very minimal examples. I want to show you how this is done in principle. We're not going to go super deep with complex examples. I'm going to show you a very, very simple example, and then one example that is a little bit more computationally intensive to show you the performance difference as well. So what we're going to do is we're going to open up a terminal. I already have UV on my system. UV is a Rust-based Python package manager. You don't have to use it. I would recommend to use it, though it makes things easier. If you have UV on your system, you can just use it, and otherwise you have to install it. You can install it either using pip, so you can say pip or pip3 install UV. You can install it as a system package on Linux, or you can also install it using a Rust package manager. In my case, I already have it. Get it on your system, and then we're going to start by installing a tool. So we're going to say UV tool install Maturin. I hope this is correct in terms of pronunciation, but that is going to be what we use to build our Rust packages. So I already have this on my system. As you can see, Maturin is already installed. And now what I'm going to do is I'm going to create a new extension project. So I'm going to say Maturin new, and I'm going to call this simple extension. And then I'm going to pass the flag bindings py03. That is just, I think is it a company? Is it a project that is behind this idea of extending Python with Rust? So now we have this directory here, simple extension. It contains a source directory with a lib.rs file. This is our Rust extension code. This is what it looks like by default. And in addition to that, now on the same level as the source directory, I'm going to create a directory for my Python code. Let's call this simple app, for example. And in here, I'm going to have a main.py file. Now, I'm not sure if that is correct, but I read online that this is a best practice to have your Python code and the extension code in the same project, to not somehow have them in different locations. Because the interesting thing is also, when we use Maturin later to build our extension, it's going to be automatically installed into the virtual environment of our Python application. So what we have here is simple extension. I can go in here and say uvvenv to initialize a virtual environment. We can also go and activate it. So source venv bin activate. And then I can go into the code of this particular extension here. As you can see, we have a module, py module here, which is called simple extension, and we have a function. The default function here is sum a string. We get just two numbers as input. We turn them into a string and then we return them. But we're going to write two simple functions here ourselves to see how this is done. So I'm going to remove the comments here, and I'm going to add another function. It's going to be again a py function, and let's call it greet name. So this is going to take a name as input. It's going to be a reference to a string. So we're going to use the ampersand and str, and that is going to return a py result, which is also going to be a string. Now, since we're returning a py result, we need to make sure that we also communicate whether everything was successful or not. This is what we do with OK. So we can say OK, and then just a formatted string. So format, exclamation mark, parentheses, and in here I'm going to say hello, and then the name. Sorry, this is not Python. It's not an F string. We do it like this. So hello name is going to lead to our greeting string. Also, the second function is going to be for summing up the values of a list. So I'm going to say sum list is going to be taking in numbers, which is going to be a vector. So vector of type integer 64 bits, and that is going to return just an integer. So py result of I64. And here again, we need to say OK, and then numbers, iter, sum. This is not a Rust tutorial, so I'm not going to go into the details here in terms of syntax, but if you know how to code Rust, you just code your functions here, you define them as Py functions, you have the whole thing defined as simple extension or as a module here. And now that we have all this, I can just open up my command line again, and in here I can say Matrin develop -- release. That is now going to compile the whole thing, and it's also going to install it as a Python package that we can access in the virtual environment. So there you go, installed simple extension. Now I can go into my Python script here and I can say, provided that VS Code is actually using the correct interpreter, which it's not. So I'm going to say enter interpreter path. Then here I'm going to go simple extension venv bin Python. And now it should also be able to do the auto completion properly. So we're going to say import simple extension. And then we can just call the function. So I can say print simple extension and what was it? Greet name. So we're going to say .greet name, and I'm going to use my own name here, Florian. And then also let's go with or what did I call it? Sumlist, list. I'm not sure. Probably sumlist. That would be correct. But let's see. So I'm going to pass a list here, and let's say the values in this list are 1, 2, 3, 4, 5. And I'm missing a closing bracket. So let's run this. And you can see hello and 15. Perfect. So we use the Rust code here as a Python package to get the result. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. Now, this is of course a trivial example, so I want to show you another one which is a little bit more interesting and also produces a massive difference in terms of performance. I'm gonna just open up a new directory here, or actually I'm gonna do this with Matrin again. So I'm gonna say Matrin new performance extension, let's call it that. And again, bindings Py03. So that creates a new project here. Again, let's create a folder perf app or something. It doesn't always have to be called app. Doesn't really matter. And I'm going to say main py. Now, what I'm going to do here now is I'm going to copy paste from my prepared code a function. It's not super complicated, but since this is not a Rust tutorial, there's no value in now coding it from scratch here. So this is basically just a simple function that finds all the prime numbers up until n. It's called, or this method is called the sieve of, let me look it up, Eratosthenes. I hope this is pronounced correctly. But basically this finds prime numbers. And if you pick a very large number for n, this can take a while. So we want to compare this function to an equivalent function in Python. So what I'm going to do now here is, first of all, I need to deactivate the previous environment because we're now in a new context, perf extension, uv venv again. And then we need to go into, or actually we need to stay here. We need to say matrin develop release. That's again going to compile everything, install it as a package. And now you can see installed perf extension. We can go into Python. I also should switch the interpreter path here now in VS Code. So perf extension venv bin Python. And here now I can say import perf extension. All right, now the Python code, also something I'm going to copy paste because there's no value in doing this manually, is going to be the equivalent functionality, but in Python. That is the Python equivalent of our Rust code here, finds all the primes with the same method up until n. And now I'm going to import something else. I'm going to also import the time package or the time module from core Python. Let me also go into full screen and zoom in a little bit so you can read this in an easier way. And now I'm going to say start is equal to time perf counter. I'm going to say end is equal to time perf counter. In here, I'm going to do the calculation. So I'm going to say pi result is equal to pi find primes. And we're going to define an n up here. Let's say n is 1,000,000 to get started. And then I'm going to say pi time is equal to end minus start. And I can then just copy this, paste this, and replace Py with Rust. Except for the function, because that's just find primes. And then we can print the time. So I can say here formatted string Python time, and it's going to be PyTime. Then same thing with Rust time. And the important thing also, the speed up. I want to see the speed up. So I'm going to say here that the speed up is equal to the Python time divided by the Rust time. That is going to be how much faster, how much x faster this is than Python. So yeah, this is kind of the slowdown, you could say. So we take the larger time divided by the slower time, and that produces the x number of how much faster this is. Not the best way to put this, but you get what I mean, hopefully. So now we have this. Let's run this and see what happens. First of all, nothing happens because it's not find primes. It is the perf extension .find primes. But now let's run this again, and you can see 14, almost 15 times faster, but this was quite fast in general, so maybe we should add a couple of zeros to get a more, a better result. So let's run this again. Now we get 11 times faster, so we have here 0.6 seconds, and we have 0.05 seconds for Rust. And as we increase this, probably the speed up is going to go down a little bit, but it's still going to be significant. So if I go with 100 million, it's going to take some time, especially the Python implementation here, but we're going to probably still get a speed up around 6 or 7 or 5, I don't know, 9 even. Okay, so we get 8 seconds for Python and less than 1 second for Rust. You can see this is a simple example. There's other things that you can try, but when you have something computationally intensive, you can also just write a Rust extension to do it, and you can then import it as a Python package. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need some help with your project, with your startup, if you need some consulting services, or if you want me to teach you something one-on-one. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.